Applications of Conduction, Convection, and Radiation to Our World by John Kennedy, Physics Project 2, Nashville State Community College through the RODP program. Heat can transfer through different ways. The first law of thermodynamics describes that energy can be neither created nor destroyed. And what that means is that even when we maybe build a fire for camping, or we create a meal to eat, sometimes we feel like we are creating something out of nothing, but really the molecules of energy and matter were already there. They just change forms. Just like when we die, our bodies will decompose and go back into the earth. The energy, the matter of who we are, doesn't change, doesn't go away. It just changes shape and transfers to something else. Where does heat energy come from? Mainly it's going to come from the sun. There are other sources that will radiate heat, but the sun is the reason through its gravity we have planets. The reason why we have heat. It's the reason why life is there. The particles of us are parts of suns that have exploded billions of years ago. So that's where all of it comes from. Types of heat transfer. There's conduction, which is when two objects are actually touching each other. One will absorb heat from the other. There's convection, which is a cyclical heating and cooling, where the hot air moves out and the cool air moves in to be heated. And there's radiation, and that's electromagnetic wavelengths that come from the sun and other objects that produce heat. So conduction. The molecules in one object begin to vibrate faster because there's a heat source, and that creates a hotter object. So you could take a ice sculpture of a swan and a burning match. And while a match might seem like it's has more energy, more heat potential, really the ice sculpture would have more because it has more molecules in it that could vibrate when warmer. If I was to be in a cold winter day inside with the fire and a heated house and gloves on, I would walk outside and grab a cold pole that's been out in the snow and ice. Then what would happen was when I would touch that pole, it would feel very cold in my hand because the molecules in my hands are vibrating at a faster rate. It's going to be hotter than the molecules vibrating on that pole. So the way the conduction heat would work, as I'm holding that pole, the molecules that are in my hand that are vibrating much faster are going to start bumping into the molecules of the cold pole that are not moving as fast. That kinetic energy is going to pass over to the pole, and the temperature of that pole will then start to come up to the heat of my hand, and the heat of my hand will start dropping some as well. They're going to find an equilibrium between the two of them at some point. Some factors that affect conduction. You've got the temperature gradient, and that's basically one part's hot, one part's cold. Heat loves to travel from high to low. You've got the cross section of the object. Let's think about a pan that you might be cooking food in on a stovetop. A pan's going to be nice, wide, and thin, so it's a nice, large surface for heat to conduct off of. Versus if you had a very narrow or thin subject that heat up, it wouldn't conduct heat as well. The length of travel, how far away are the molecules from each other? Is the hand near a pole, or is my hand grasping a pole? That's the distance there. And physical properties can affect heat transfer. Metals conduct heat very well. Objects like rubber and other organic substances do not transfer heat well. Those we call insulators. You might think about insulation in your house, in between the walls or up in the attic, trying to keep the cool air or the hot air inside, not let it conduct through the walls to the outside world. Because remember, it likes to go from hot to cold. So if it's hot outside and it's cold inside because you're AC, then the hot air is going to try and get into your house. Vice versa. If you're hot, if it's wintertime and you get your house heated and it's cold outside, the heat's going to try to escape. So insulators are going to try and prevent that transfer of temperature. It's a good example of it. So that's a spoon and a hot cup of liquid. As you can tell from the red color, the handle of the spoon is getting hot. And so that's the heat from the liquid conducting into the metal spoon, which if you grab that spoon would be pretty hot. Conduction is the most common type of heat transfer. And we pretty much covered the rest of that. So, the equations for conduction: Q equals K times A times T hot minus T cold, and all that divided by D. Q is the heat transfer per unit of time. K is the thermal conductivity of the barrier. A is the heat transfer area. T hot is the temperature of the hot region. T cold is the temperature of the cold region. And D is the thickness of the barrier. Next, we got convection. So in convection, you have fluids. Fluids could be a liquid. Fluids could be a gas. And they're going to be heated. They're going to go through a heat source. It's going to, again, those molecules are going to vibrate more. And because they're going to vibrate more, they're going to rise up in the air. So that hot air is going to rise. As such, it pushes the cool air down to that heat source and creates a circular pattern of hot and cold. Just like this picture shows. So the blue arrow is the cooler air being pushed down, the red is the hotter air coming up. The ways convection affects our life: cooking, as the picture shows, whether you're baking in an oven or water in a teapot. Weather, thunderstorms and convection in the world of weather can be interchangeable. Thunderstorms is when hot air, cold come through. And the fitness, people going to saunas and spas and such and trying to sweat and lose weight. Crawl up to an attic space. Lava lamps actually are a good case of it. As you see the wax taking different shapes and moving up and down, that's convection heat moving in there. Hot air balloons, as they use more heat and heating up the air. That air wants to rise, which is caught by the balloon, which brings the hot air balloon up. The convection equation is Q equals Hc times A times Ts minus Tf. Q is the heat transfer per unit of time. Hc is the conversion heat transfer coefficient. A is the heat transfer area of the surface. Ts is the temperature of the surface, and Tf is the temperature of the fluid. The third and last type here we're discussing in this presentation is radiation. Radiation is unique in fact as it does not require two objects physically touching. It can survive in the vacuum of space, and the sun is probably the best example of it. The sun is going to send electromagnetic waves towards the Earth in the form of infrared light, and it's going to heat up the ground, it's going to heat up the air, people, everything. It basically provides the ability for us to have life on this Earth. Radiation equation, P equals E times O times A times TR to the fourth power minus TC to the fourth power. P is the net radiated power, A is the radiating area, TC is the temperature of the surroundings, TR is the temperature of the radiator, E is emissivity, and O is Stephan's constant. Conclusion of all this is how I've discussed how all three ways of heat transfer are different, but it's how they all work together in normal life. So radiation comes from that fire or from an electric current on a stove. That radiation is going to heat up the pan. The pan, as it gets hotter through convection, is going to heat up the molecules of the water itself. As the water is becoming hotter, pushing the colder air down, and that cycle of thing, the handle, which is attached to that pot, is also getting hot, and that's through conduction. That's why you end up using a cooking mitt or a rag or some other form. Sometimes handles of pots are being made in ceramic materials, so it won't conduct heat as well. And then references, 6 references we use for this. Hopefully, get an idea of what heat transfer is, how it can happen through conduction, convection, and radiation, how they all work together and have a little bit of differences as well. Remember, radiation does not need to touch something, conduction does have to touch something, and convection is a cyclical pattern. Thank you.